Okay, good morning. We're going to carry on with our triangulation, and in this video we're going to look at triangulating a round to round. So a round taper of some sort, conical shape. This would be one where we've looked at radial line, and some of the items that we need to use radial line won't work. Okay, and so in those cases we transfer to triangulation. So this one, off center. Okay, so that's an off center cone. So it's not a right cone, so radial line won't work. And if we stretched it out, if we kept those lines going, the outside edges, we're going to have an apex that's fairly far away. Okay, it might be up here somewhere. Depending on the space you have available, is dependent if that will work or not. Okay. So we've looked at radial line nonetheless, and it's not going to work for us. So we're going to triangulate it. And here's my little sample I have, showing a round to round, just a small one. And that's sort of what an elevation view would look like if we had it, is a zigzag of lines from top to bottom. Okay, we have our profiles on both ends. And then if we looked at it this way, here's what sort of our plan view is going to look like, couple of half circles or full circles in either case. But if we look at the side of it, looks at that way for a bit, we see a profile height at one end, okay, these different heights here, compared to the profile height at the large end. Okay, and if we scribed a line straight across from the small end, the difference between the height here and the height there on each of these points gives us our little 90-degree triangle. Okay, so what we're looking for is a small end height of, say, that, and then we have our length, and a large end height of that. We're looking at something like that, right? And we have these triangles inside, but a lot of the triangle includes a rectangular portion, which is down here. Okay, that would be inside here. So from this height straight across gives us that rectangular part. And then we have the hypotenuse that goes up here. Okay, and that's our outside edge. Again, that's our element line. Okay, the hypotenuse again is our element line. So if we take our lines, if we take off the square section, okay, so we minus the small end from the large one, and the difference, this is the difference. And we refer to that as difference in profile heights. Okay? Take this one, cut off the rectangle, that gives us our triangle. Okay, with our hypotenuse, 90-degree corner, vertical height here, plan length here. We're going to see that when we draw the plan view, but the difference becomes our plan view length. Against the vertical height again, the hypotenuse becomes our true length. Okay, well, let's see what that looks like when we actually draw our plan view. So let's clear that off. Now, circular shapes are different in a few different ways, but in one way, for sure, is when we take two circles, we're always going to have a line of symmetry. Okay, it doesn't matter where you put them. You can't make two circles off line of symmetry somewhere. No matter how you orientate them, you'll always have somewhere to go through both of them. Okay, so we can have one here and one, anywhere we choose to put it. We will always find one line of symmetry. So that means we always can get away with just drawing a half plan view. Okay, so let's give an XY axis here to start. Now we're going to start with on center fitting. So everything's on, and when we refer to it, it's either on center or off center. A squared around, we can have multiple ways. We can have totally on center one dimensional, or off center both ways. We have a few more ranges with a squared around. But around to round, it's either on or off center. So we're doing on center. Okay, so we get our first circle drawn. And while I'm here with that radius, I'll divide it. All the way around. Because I want to keep the clarity of what we're doing. And sometimes the more we draw, the clearer it becomes. Sometimes not. Sometimes it's clearer to do less drawing. I find with layout, the more we draw, the clearer it becomes. And let's go to here for our large. And we'll divide it. Or left and right both ways, up and down. These are creating 60 degrees for every step off or for every swipe of our dividers. And then we break that in half, so 30, 60, 90. Okay, so there's the start of our plan view. And we got our small circle, our large diameter, or large circle. And now we want to draw on some element lines. Okay? If we looked at, we don't need to draw a complete one out, but let's just have one to reference. And let's call this 12-inch diameter and 8-inch diameter over a 8-inch height. Okay, so we've taken that view, the elevation view, and we're looking at the plan view from there. So when we do on center cone, it doesn't matter where we put the seam. There's no differences anywhere. Everything's all going to be the same. So let's put our seam here. Okay. So putting our seam there, we want to label it accordingly. And what we want to do with a round to round, and one of our second differences between a square to round is it's got two rounds, so that means we're going to number everything. So we don't have our same pattern where we go letter to number or vice versa. Tells us that it needs to be put into a true length diagram. What we're going to do in this case is stagger or zigzag from odd to even. So there's our first element line. Small to big. Back to small. Back to big. Back to small. Big, so on and so on. We zigzag around. You'll see these are all odd numbers. Outside the large, I've made all even. From 1 all the way to 14. Okay? So now in this case, and we want to keep our plan view to reference, but if we're going from odd to odd, it's a true length here. That's a step off. If we're going even to even, it's a true length in the plan view. Again, that's a large step off. If we're going from odd to even is when it needs to go into a true length diagram. Okay, so this shows us our pattern of how that labeling works. We want to keep it there as reference. Okay, knowing that even, step offs, odd, step off. If you go between them, that's where we need to triangulate the true length. So let's make our true length diagram here. Again, I'll tick off my height. I'll give myself just whatever at the bottom, as long as I know that one of these can fit in there. That's if I take ballpark as the longest element line, from the plan view, I know that everything's going to work. So now we've got our plan view complete. We've started our true length diagram. We have our vertical height here, which is our 8 inches. Goes to here. That's our vertical. And then we're going to take our element lines from the plan view and put them 90 degrees to the vertical height. So I'm going to take line 1, 2 and put it in on the horizontal. One dash 2, that's my line. Okay, then I'm going to take 2, 3. Dash 3, and so on. 3, 4. Well, 3, 4 going from odd to even is going to be a repeat. 3, 4 will be the same as 1, 2, will be the same as 5, 6, 7, 8, 9, 10, etc. All these ones will be the same when it goes odd to even, are all the same. 3, 4 again. Okay, so we can do that. We got 3, 4. We got 5, 6, we got 7, 8, 9, 10, 11, 12. Same on the other side. We got 2, 3. Now we're going odd to even, the opposite. When we go back, they're different, but they're all the same again. Okay, so we have one that goes straight across, and we have one line that's angled across. And those two are different, and those are the only two different ones we have, because anything that goes straight is the same. So 7, 8 shows it here. And anything angled is different. So 2, 3 we have. We got 4, 5. We got 6, 7. We got 8, 9. We got 10, 11. We got 12, 13. And we need 13, 14 here to finish it off. I left that one out. And that gets us, we know that we got all the way to 14. So we start at 1. We got every number, every line in there all the way to 14 now. But to follow suit, just pick up each one following the number line. 1, 2, put it in. 2, 3, put it in. 3, 4. You can't skip a number. Okay, you have to go with the number line. 1, 2, 3, 4, 5, 6, etc. Okay, we're ready to start our pattern now. So with a squared around, we started with a horizontal, AB. In this case, we're going to start with a vertical. Like that. Okay, for my purposes and the room I have, I'm going to work one side all the way through. But as you're doing any round to round, you're going to want to start at the center point, working towards your seam. Okay, you work both sides equally all the time. It's a mirror image, so if we start here, it doesn't matter. We're going to do the same thing outwards. Excuse me, we're starting here because that's where we picked to put our seam on. But we're working both sides the same. Okay, we want to imagine the mirror up here. So we label it back 13, 12, all the way back down to 1, but that's up to you if you want the clarity. Okay, so I have a vertical there to start with. I'm going to give myself a starting point, let's say right here. Okay, and that one, I'm going to put my large end at the bottom, so I'm going to label this point 2. And it doesn't matter that we start with point 2 instead of 1. And sorry, let me start over. We're going to go with 14 because we want to end at 1, 2 where our seam is. So if I have point 14, I want to get to point 13. And that's not a triangle to get there, that's just a line. So I want to pick up the true length of line 13, 14. And that is here. And I swing that point off. Okay, and that becomes 13. From 13, you have to follow the number line, remember? So I'm going to 12. So I find 12, 13. 12, 13 is here, so I pick up that one. And I swing it from 13. To finish that one, I need my step off. That's true length here. So I pick up the step off to finish point 12. This one really comes in handy to have a couple sets of dividers or two compasses, because we have the one step off for the small end and we have the one step off for the large end that get repeated over and over and over again through the whole fitting. So if you can set those up and just leave them, that really saves you a lot of time. Okay, so we're going 12 to 11. 11 to 12 is here. Pick up the true length and swing that from 12. 13 to 11 finishes that point. That's 11. Again, once I have this set, I'm just going to pick it off for the next point when I come to that later. 14, 13, 12, 11, 10 next. Okay, we're going to come down to 10 here. So 11, 10. True length. And our step off. Ten. 9, 10. I already had my step off. And that becomes 9. Okay, we're just going to continue this process until we get it all the way through. Okay, so that completes our pattern all the way through to 1, 2, and then we can draw in our lines. Now, again, unlike the squared around where we had our wings to check, we do not have something like that on a round to round. We don't have that checkpoint or something that stands out. Besides having, again, a smooth arc. Okay, there shouldn't be lumps and bumps in it. It should be fairly consistent as far as an arc. Okay, so that's a half. You would have worked out the other side, but I didn't have room. So as you're working this side, make sure you're working that side. Same process. Okay, one triangle after another. You're building on 2 known points, creating the third. Then you get 2 new known points, create a new third, etc., etc., and stack those triangles in. And if we follow our number line, 14, 13, 12, 11, 10, 9, 8, we get all of our triangles that we built. Okay, it's one triangle after another. Find the two known points, create the third, and then stack them one over each other. Round taper, triangulation.